Good morning. I'm Simon St. Laurent. I'm a senior editor at O'Reilly Media Inc., and we're here this morning to talk about functional programming and a good deal about Erlang. Steve Vinoski, who's here with me, is an architect with Basho Technologies, the makers of the React database. He's been working in the industry for nearly 29 years, and he's focused mostly on distributed systems, ranging from hardware and embedded systems to enterprise middleware to more recently web systems. Over that whole time, he's focused on teaching teams to use languages that fit those projects, which can be a challenge in itself. Steve is a frequent conference speaker, and he was a magazine columnist for a total of 17 years for the C++ Report, the C++ Users Journal, and the IEEE Internet Computing Magazine. You've been at this a while, but what brought you first to functional programming? What drew you in?
Well, I got to think back to that. I started my career working for Texas Instruments. I was a hardware developer, and I was the most junior person on the team, so we needed some testing for the hardware, and they said, well, you're the most junior person, so you get to write the tests. And I had no software background to speak of. So I had to learn software, so I just started buying a bunch of books and teaching myself software. I didn't know anybody who knew software. There were no team members or nearby teams that were writing software, so I was kind of all alone and reading from these books and learning about structured programming and Pascal and C eventually, and then C++. So by the time I left there, I went to Apollo Computer. Finally got to go work with some software people, and there were a lot of senior people there, had a wide variety of interests, and from them I learned to kind of look at tools and look at things that can make your job easier. So I was working on things that needed kind of domain-specific languages. We didn't have that term back then, but that's really what they were. So I started looking into things like ML and other languages that, like Lisp at the time, were functional languages, but were very, much not used, I guess, only in certain circles. So that's how I got into it. Through the 90s, I can't say I really did anything with it because I was doing pretty much all C++ in the 90s and some Java. And it really wasn't till mid-2000s, I guess, that I found Erlang and got back into it.
What brought you to Erlang? How did you land there?
That's a good question as well. So my background, starting in the early 90s, I started working on what was Corba, the Common Object Request Broker architecture from the OMG. And we were developing in C++, but we had to deal with a bunch of different languages, and it was a distributed system. And in a distributed system, you need to be able to find things. You have discovery and naming, and you have, of course, messaging between components in the system across the network, or locally on the same machine, or what have you. And so we ended up building all these components in C++, in Java, that could do the communication, could do the discovery and naming, trader services, all kinds of different, network services that you could put into these distributed systems. And I was working at Iona Technologies from 1996 to 2007. And around in 2004, they gave me a new job, which I was kind of in charge of innovation. So one of the things I was thinking of during that time was how could we reduce cost of maintaining the code that we have. And, we had a lot of C++, a lot of Java code. So I started looking at Erlang because it had these distributed systems capabilities that I thought might be interesting. And every time I looked at it, I would look at it a little bit, and I'd say, I wonder if it could do, does it have this kind of service? And sure enough, it would have it. What if it could do naming? Can it do messaging? Can it do, whatever, all these different things I was thinking of. And every time I looked at it, it seemed to have an answer. So I started playing with it and found it to be so much easier than what I'd been doing. So I think at the time I was writing things or saying things to my friends like, I feel like I've wasted my career because I've built these systems for years and years that kind of got to where I wanted them to be, but they always had like warts here and there. And here I find this Erlang system that does everything I've always wanted, and it's already done for me. So
Yeah,
I was happy and sad at the same time.
well, it's a comfortable feeling to find home. It's just, there was this journey there that might not all have been as exciting as you would have liked.
Yeah,
Um,
that's a good way to look at it.
it seems like you arrived a little bit ahead of the crowd. You know, distributed computing has become a much more common thing in the last few years.
Right.
Even the simple level of distribution inside our computers with multiple processors.
Yep.
So you kind of got there before everybody else did, and I guess I wonder how everybody else coming to distributed computing changes the kinds of conversations you've been able to have about what you found.
Well, it's been interesting on several levels. First, distributed systems kind of used to be a bit of a niche. I mean, for us, it was everything. It seemed like, everybody wanted to do it, and all the companies we worked with, I was at Hewlett Packard before I was at Iona after Apollo, and we did a lot of, we had both research and product development doing distributed systems from the late 80s through, the mid 90s. And then I left there to go to Iona and continued that kind of work. And of course, the web came along strong in the latter half of the 90s. And so systems started to get distributed because people wanted to take advantage of the web. And what we've been noticing, some colleagues and I lately, is there's you could call it a distributed systems renaissance.
Mm-hmm.
I'm actually having a track by that very title at GoTo Aarhus later this year in Denmark in September, and hope to have some good speakers speaking at that track. But it's kind of that there's a ton of research going back to 60s, 70s, 80s, 90s, continuing until today on distributed systems. And what's happening now is you're seeing people either, I guess, accidentally or just kind of by having to work through the problems, kind of stumbling upon these old research papers and old ideas that still are valid and were discovered 30 years ago. So it's kind of interesting to see that. You see it in the form of people finding, they'll say, hey, I just figured this out, isn't this cool? And then you could say, well, yeah, so-and-so did that back in the early 80s. Or they actually go and find the relevant papers and say, wow, this is exactly what I'm working on right now. I'm so glad to have found this work. So it's interesting from that perspective as well.
Yeah, everything old
And
is...
I think one other thing about it is it hasn't gotten any easier. It's always been difficult. And just to reason about distributed systems, of course, hasn't gotten any easier. And you hear about, the fallacies, distributed computing, and all those kinds of things. They remain true today, and people need to know that stuff.
Yeah, it seems like everything old is new again on a perpetual cycle. It just keeps moving through. Well, one thing that I keep finding happens with people who are discovering this is some of them decide to make the great leap, and they just, change languages, they change approach, they change everything. Other people, especially people who are working on projects that are already in a particular system, don't have as many options. So they try to find ways to do, say, functional programming in Java or JavaScript or Ruby.
Right.
You seem to have made the great jump, which is, I think, a lot easier if we can do it. But are there options for people who are sort of stuck in that halfway zone? Or, at some point, are they just going to have to leap?
I guess I did make a leap in a sense. The timing was good because I was at Iona and I was trying to convince them to use Erlang, and they, for good reason, did not want to. They actually did look into it, evaluate it, gave it some serious thought, decided not to do it, which in hindsight was exactly the right reason because economically it just didn't make sense to go and redevelop a bunch of that software, which was kind of, getting not end of life, but, approaching the downslope for sure, or on the downslope, I should say, of the end of life of that software. So then I joined a new company called VeriView, which was a startup. And when I talked to them about joining, I mentioned Erlang, and they said, oh, yeah, we should try that. So I kind of had a good jumping point. For people who can't do that, which I'd say is probably the majority of people, I'd say that it definitely is worthwhile trying to take the language you're working in and use functional concepts. You can go read about functional programming in a number of places, and it's become more popular now, so you get a lot more people writing about it. The concepts do take some getting used to. Call it immutability. You'd like to have a language that enforced immutability of data, but if you're in a language that doesn't do that, it's kind of hard to practice that, for example. But there are other things like mapping over data sets, folding over data sets, these kind of operations that are very, very common in functional programming. You can still do that within a language that doesn't necessarily have those features, but you could build them yourself. It's a nice way to learn about those features, and it kind of twists your thinking about how you approach problems. There's also ways, especially with Java, where you can take languages like Clojure or Scala, still get access to all of your existing classes and libraries, and yet have the benefits of functional programming. So that is, well, it's not a huge leap, right? It's a little jump. Those languages aren't trivial to learn, but they're not all that difficult as well. And plus you have the base underneath, the JVMs underneath, and if you're familiar with the JVM and how it works, all that stuff, you don't have to throw that away.
Yeah, I was just reviewing our Scala cookbook recently and marveling at just how similar it felt to the Java that I used to do. So
yeah,
there's a lot of it. I guess the other place that I see people moving, the other way I see people moving to functional programming is through the web. So you'll set up, part of your application will be whatever you were using before, and then you include services, or you include, something running on a different web server, and you can kind of bring it in little by little. I haven't done a whole lot with Yaws, for instance, but I've heard of people, working with that. We have a book on it, mixing services into their systems and taking advantage of the functional resilience for stuff that really has to stay up, and not worrying so much about the other details. But you've worked really pretty heavily with Yaws. I think that might be a fun story, if you could kind of explain how you got there and what you've done.
Well, Yaws was, I found that, I think in 2007. So I had started working at VeriView, and we were building a video server. So it was a chunk of hardware. It was a pretty high capacity video system, and it had up to 48 terabytes of flash storage, up to 10 delivery boards, up to, I guess, 2 ingest boards. So you could deliver at 200 megabits per second, ingest video at 20 megabits per second. And it ran Linux, so all these boards were all running Linux. So it was like a little distributed system in a box. Well, not that little. It was 14 rack units of distributed system in a box. And there was a smaller version that was, I think, 3 rack units. And we wanted to be able to deliver video both for cable companies, so typical like Comcast or Time Warner, those kinds of companies, and then internet video as well. So the box was going to serve kind of double duty. I was working on the internet video side, and we needed a way to handle a lot of traffic, web traffic coming in. So I was looking for something that could specifically handle a large number of connections. And I tried various web servers, and because I had been looking into Erlang, I found Yaws and started looking at that, and it seemed to do what we needed it to do. So I was working on it, and I was finding little things that could be improved, things that I could add to it to make my job easier, and became friends with the guy who developed it, Claus Wikström, whose name is Klacke. He's a Swedish guy, one of the old-time Erlang programmers from way back in the early 90s. And he brought me in as a committer on the Yaws project, so I still do that. In fact, I was working on it this morning before the interview. And so Yaws has been interesting because it's a full-fledged web server. You can use it in an embedded system. You can use it in like a full-blown web serving system. It's got support for all kinds of stuff in it. Lots of JSON support. It's got, WebSocket, server-sent events, the ability to stream stuff. Streaming video was what I was doing, so I added this ability to have different Erlang processes handle the streaming and be able to fit that into Yaws easily. So that's been in there for a few years now. So it's very capable. Some people kind of, if they're looking at Erlang for the first time or they're kind of new to it and they find Yaws, some of them find it overwhelming just because it has so much support in it for a wide variety of things. But all the support was added by people who actually were using it, and they make use of all those features. So that's how I got to Yaws, and like I said, I still work on it today.
It seems to get a mix of uses. It's definitely an easier way to put a front end on an Erlang project for a lot of people. Your streaming is I think a pretty intense use of it. And it seems to, really be aimed at scaling to cover as many connections as necessary at any time.
It's one thing about Erlang in general is that it's not hugely fast. If you go and you find people who are kind of new to Erlang, they say, "Oh, look how fast it is," and it's not hugely fast. It's more for control, not for data streaming and that kind of stuff. So when you think of control plane and data plane, control plane Erlang is really excellent at. The data plane, it's adequate, but you would never do it for high speed data delivery, that kind of stuff. You would probably be better off with something like Nginx. In fact, at VeraView, we did find a use case that needed a certain amount of streaming capability that we did use Nginx for because it was faster. And, it's nice to be able, going back to your kind of services stuff you were talking about earlier, it's nice to be able to mix things like that. So we could mix having an Erlang web server handling control and, distributing control over all the boards in our system, and then use Nginx to really just pump data out as quickly as we could. So Yaws is good at that kind of stuff. If you need like super, super fast data delivery, it's probably not the best thing. But if you want something that's relatively easy to get going, has a wide variety of features that, as you develop your system, you find you need this or that or the other thing, you might find it's already there in the package for you.
That's a great foundation. The company you're working for, Basho, is probably best known for Riak, which is another way to put Erlang into the back end of an enterprise, and people are connecting it to lots of different things there as well. So you kind of get the advantage of Erlang's power and distribution. But so far as I can tell, most people using it aren't Erlang programmers. They're people who are happy to have an Erlang subset in their system. Could you talk a little bit about how that drives things and what people can look for?
Sure. So we do get some of the Erlang crowd looking at it because it's Erlang, and of course Erlang, Riak as a database has to support a wide variety of application languages. So it supports Erlang, of course, but it supports Java and Ruby and Python and JavaScript and C++, and you kind of name it, it's supported either by Basho or by the community because it's an open source system. So some people have added, for example, .NET support and C# or that kind of support. And so yeah, we do get developers who come to it from the Erlang community. We get many more coming from other communities. And what happens with some of them is they They say, well, I want to use it for this project. I'm going to use the language I know, but I'm also going to use it as a bit of a gateway to try out Erlang and see if I can make use of that in my system. Erlang is also very good at integration, and that's kind of little known. I think people think, when you adopt Erlang, you kind of take it and it sits over there by itself. But because of its distribution capabilities, you can really attach anything to it over the network, of course, but it also has a nice foreign function interface for C, C++, and also for Java that if you want to build parts of your system in those languages and then integrate them directly with the virtual machine, the Erlang virtual machine, you can do that as well. And that's how Riak is built. Most of it is written in Erlang, but when we have to integrate with data stores underneath, for example, we have integration with Google's LevelDB. That's done using C++ because LevelDB is written in C++. So we add a layer over the top of that is a shim between Erlang and C++, and that works really well. The Bitcask backend is something that Basho developed, is also written in using this same foreign function interface.
Yeah, it seems like a fair amount of the traffic on the Erlang questions list is people building various connections. It's kind of fun to watch the different styles of building and people looking at, you're trying to do X, Y, Z, this is the right tool set for that. And there always does seem to be the right tool set for it someplace.
Yeah, I think a lot of people have built little components over the years that, especially with the rise of GitHub, you can kind of go out and find these little projects that do what you need. And the nice thing about Erlang, and I know you found this as you were learning Erlang and writing your new book, Introducing Erlang, you can go and grab a piece of it and start looking at it, and then you kind of work through it and say, all right, I'm ready for the next batch of the language, but you've already gone through the whole language. There's just not a huge amount to the language itself. And a lot of the patterns that are useful in the language are already captured in the form of these behaviors that come with the language that are part of the Open Telecom platform, or OTP part of Erlang. And with OTP, you get these things, like generic servers and finite state machines that if you were thinking about how you might solve a problem, you kind of arrive at something like that and you say, okay, now I got to go write one of those, and you say, oh, I don't, because it's already written for me. So they're in the package as well.
Yeah, it's a nice combination of a small language with a major library component, and then the extensibility you mentioned earlier. I guess the last thing I want to mention is it seems like there's kind of an Erlang ecosystem growing. It's not just the language and the OTP libraries. It's Riak, it's Rebar, it's Yaws, it's a whole set of projects that, for the most part, seem to play pretty nicely together. And as far as I can tell, actually have kind of a core common community, which is unusual. Could you talk a little bit about kind of that growing ecosystem and pieces you see that are especially exciting?
Yeah. Well, let's see. There's a piece called Web Machine that was also developed by some Basho employees, led by Justin Sheehy, who is the CTO of Basho.
It's the best.
So Web Machine is...
It's the best. It's the best diagram I've ever seen. That one giant. Here's how to process. Yes.
Yeah. So if you took HTTP and made a flowchart out of it, which a guy named Alan Dean did, he built that flowchart, and then Justin said, "Hey, I can write an application in Erlang that can actually create that flowchart or implement that flowchart." That's what Web Machine is. And so Web Machine's kind of cool, especially when you use its visual debugger that gives you that flowchart of HTTP status codes and stuff, and you can see where your application is making its decisions in the flowchart. So that's kind of neat. But Web Machine itself is like HTTP personified. It enables a lot of RESTful applications. It doesn't automatically make them RESTful, but it gives you the right hooks that you need to make that happen. And Riak's HTTP interface is actually built on Web Machine. So recently I took Web Machine, which is built on top of a web server called MochiWeb. That's been around for a while. Bob Ippolito is the guy who wrote MochiWeb. Andy Gross is Basho's chief architect. He also contributed quite a bit to MochiWeb. And they were actually looking at yaws back in, say, 2005, 6, 7, I believe.
Mm-hmm.
And Bob was building his startup on that, on an Erlang web server. And he was using yaws, but he said, yaws has too much stuff in it. I only need this little piece over here. So he kind of started MochiWeb by taking that direction. And so MochiWeb in itself has become a very popular web server. So Web Machine's built on MochiWeb. And recently I took Web Machine and I took a fork and put it on top of yaws.
Mm-hmm.
And then there's another web server that is newer today in the Erlang world called Cowboy. And one of my colleagues, Andrew Thompson, took my fork of Web Machine working on yaws and got it working on Cowboy. So those two forks haven't really been brought back into the main Web Machine repository yet, but that's something I hope to do over the next couple months. And so like you said, there's this nice ecosystem developing. That's one example that happens to be in the web world related to Erlang, but there are others as well. I guess the clients I mentioned earlier that are built for Riak, some of them use the HTTP interface, some use the protocol buffers interface. They're both, people who work on those things do tend to have to know a bit about the Erlang side to get their clients working. There's CouchDB, of course, written in Erlang as well. Just a whole variety of different projects out there. People using it I've heard within Facebook, within Amazon. You don't get a lot of people talking about those projects, but I've heard that they're kind of behind the scenes up there in big companies like that. So there's an Erlang Factory conference coming up in San Francisco in March. I think it's right around March 20th. And, you get people coming from all these different companies these days that come in to talk about the projects that they're building with Erlang. So if you're interested in that kind of thing, if you're thinking about using Erlang in your own company, but you're not quite sure where to get started, coming to Erlang Factory San Francisco would be a really great way to get started because you meet the community. The community is super, I'm sure, as you've found out. It's just really pleasant, nice people that just kind of get their jobs done. There's never any flame fests on the mailing list. Just kind of the IRC channel is busy constantly, people asking questions. And then if you look at Stack Overflow, where you have all these questions, I've noticed lately there's been a lot more kind of beginner style questions about Erlang on Stack Overflow. So that seems to indicate that yet another wave of people are joining into the community, or at least thinking about joining the community. So I think they're in for a treat, should they make that jump.
Yeah, I've had a couple of conversations with people who encountered Erlang through Bruce Tate's 7 Languages in 7 Weeks, and they got through it, and they're like, that was cool, my brain exploded, I gotta go do Erlang now. Now I'm sure there are people who are doing the other languages too, and I'm getting a biased sample of Erlang, but it's fun to me to hear, people who went out exploring and, came back with, I found it, I found what I needed, this is right.
Right.
So.
Yeah, the one thing that I'm sure you've heard as well is the syntax argument. The Erlang syntax is kind of derived from the syntax of Prolog, and of course, not a lot of people know the Prolog language. So when they see it for the first time, they kind of go, what is this? It doesn't have curly braces in the right places, and it doesn't have semicolons in the right places, so I can't use it. So a lot of people will try it for a day or two and just get turned off by that lack of C-based syntax that they're used to, and then they'll go elsewhere, which is really unfortunate because the syntax is actually fairly regular once you get used to it. It's different than what you know, but it's very minimal. It's regular. It's a lot like English if you are aware of where to put commas and semicolons and periods.
Yeah.
The same thing works in Erlang.
Yeah, I was happy. I found it a comfortable syntax. It was nicely different from the JavaScript stuff I was doing, so I didn't find myself typing the wrong language in.
Right.
I've also been poking at Elixir, which is, builds to Erlang files, can use the Erlang libraries, but feels more like Ruby. That's another we'll see how people do building to the Erlang virtual machine. But it's great to see that, all kinds of different things are happening in this space.
Yeah. Elixir seems to be getting some traction. I have not looked at it myself, but some of my colleagues have been looking at it, and I have yet to hear anything bad about it.
Mm-hmm.
And as you said, it's built on top of the core of Erlang. So you can imagine, in the Java world, you have Java, the language, and then the JVM, and you have Scala, and you have the JVM. So you have these different languages with their own syntax, Groovy, etc., Closure, mm-hmm. right? All built on the same VM. And that sort of thing is also happening in the Erlang world, albeit at a slower pace because the community is smaller. You have Erlang, the language, then you have LFE, which is Lisp that's built on top of the Erlang core. And now you have Elixir. Oh, there's also something called Joxa, J-O-X-A. Mm-hmm. That's, I believe, also a Lisp built on Erlang, and then Elixir, also built on Erlang. So it's nice to see that variety where people are trying to bring different ideas. And that kind of goes back to what, when you read my bio, I talked about the idea of using languages to get your job done. Mm-hmm. Not pursuing languages because they're cool or because they're different or because, just for curiosity's sake, but actually looking for an edge in the way you develop your software and finding a language that fits the problem you're trying to build and minimizes the amount of code you have to write, minimizes the amount of maintenance and debugging, and really just empowers the programmer to get their job done. So it's nice to see that effort being expended in the Erlang community to see if there are other languages that can sit on top of this distributed systems, high availability, highly reliable core that mm-hmm. Erlang gives you, and yet gives you the language that fits the way you like to think about the problem.
It's great. I think we've got a bright future ahead for this space, and there's a lot more to look forward to. So thank you very much, Steve. Yep. I'm sure we'll have more to hear about in the near future. Thank you very much.
Yep. Thanks.